Hello, I'm John Rinaldi again with another video. Today, I'm going to talk about something that I love. There's a show on cable called Mysteries at the Museum, where they dig into some museum, in a back drawer they find some weird thing, and there's a whole big story about that. Well, I'm calling this video Mysteries at the Museum, John Rinaldi style. So, in my office, I've got relics of all this old legacy technology. And so today I'd like to go through some of the 5 legacy protocols that all of the old timers probably know about this kind of stuff, but maybe some of you new people who have just graduated from college in the last 10 years or really haven't heard much about it. So let's talk about some legacy technologies that have been around for, well, nearly ever. So the first one I want to talk about is DeviceNet. DeviceNet is where I cut my teeth on non-serial communications. Now, this is the reason that DeviceNet was so special. It's a connection-oriented protocol, different than what we do, a message response protocol that we did before DeviceNet. What's interesting about DeviceNet is it's not a terribly fast network. It's master-slave. It has probably up to, I think it's 125K to 500K. So it's not really fast. It uses SIP. SIP is the communications technology that the ODVA promotes, and it's used in Ethernet IP, and it's used in CompoNet and some other things. So SIP is an object-oriented structure for all of the data. So that was also special too. So this came out about 1995, probably before some of you guys were born. And in 1995, this was revolutionary. It was a way for people could easily interconnect to an Allen Bradley PLC in an open fashion. So this was really cool technology. It's a network with drops, and the nodes are all on drops, and typically the PLC is one of the drops, and then you have sensor actuators at all of the different nodes. And you could have, I think it was up to, I forget what the node count was, maybe 32. I can't really remember honestly on that was, but it's still used today. It's kind of on the way out, but you still find a lot of it. The big application for this was conveyor lines, because you could put this along a conveyor, and you could have all different, every section of the conveyor could be another drop. So this was really cool technology. Sold hundreds of thousands of units of this, and it's still around quite a bit. In lots of factories you find DeviceNet. Good technology, but it's just, at 125 to 500K, it's pretty slow. At 500K, you have a smaller node count, you have a smaller network. Along the same lines, there's Profibus. Now, the cool thing about Profibus that made it really special was 12 megabyte operation. That was massively, I can't tell you, you can't imagine in 1990s, a 12 megabyte network was incredible. No one could believe that you could go that fast. So this also is master-slave kind of network. It also is, you also have drops and things like that. The big thing about the problem with Profinet is the data representation is everything looks like a PLC. So you address things by rack, slot, and point. So it's a little bit awkward to fit to make a device look like a PLC and fit into this rack, slot, point kind of architecture. But it worked well with Siemens PLCs. It was used all over Europe. And you also need to have, just like DeviceNet, you need to have a chip inside of it to do that 12 meg. Typically, DeviceNet uses CAN as a basis. This uses serial, but a special serial. So this is actually RS-485, and with special chips to make it go that fast. So you needed to buy special hardware to get on both Profibus or DeviceNet. So that was called, those are both sensor networks. Let's digress a little bit, and let's go to something called a hardware replacement network. That's something called ASIBus, AS interface. AS interface, they called ASI. AS interface was just like what I said, hardware replacement. Instead of having a bunch of pieces of hardware with direct I/O connections, you could just connect them all up to the bus, and then you do that. Now this was just for very low I/O counts. So you could only have a few I/O points here, but it was extremely fast. Extremely fast, on the order of 5 milliseconds to get data. So this was good enough for lots of industrial automation applications. With it used to do hardware direct connects to a PLC, you could now do OSI-bus and just replace that hardware with OSI. So this was used for lots of different kinds of I/O applications, for mostly just for sensors. If you think about this, so this is really the forerunner to I/O Link. I/O Link is a lot more integrated, a lot more easier to install. Though OSI-bus is easy to install, this has kind of fallen out of favor. I/O Link has really surpassed this. And you're still going to find a lot of OSI-bus if you walk around different kinds of plants. Again, you need to have a chip inside. So common theme here of what we're talking about is all of these technologies generally had before Ethernet, they all had a specific chip inside that did the electrical interface to the bus. So I didn't have a lot of experience with OSI-bus over the past, but I still know there's quite a bit of it out there. Okay, let's talk about another one that this is an Allen Bradley technology, DH+, Data Highway Plus. There's actually, when somebody says I have data highway, well, this is generally the blue hose. If you walk through an old plant and you see a bunch of blue cabling, that's the blue hose. That means it was DH+. But there was actually 4 different kinds of DH+. There's data highway, there's DH+, DH2, and there's DH485. So and different kinds of Allen Bradley PLCs use different ones of these. When I was at Allen Bradley, we used to call this, as instead of data highway, we called this data sidewalk, because it was much slower than DH+. The thing about DH+ is it uses PC cubed, which is an old protocol that you understand, where everything looks like a PLC. It's kind of like the Profibus example. So you have to make your device look like a PLC to be on this network, and you also needed special hardware to do this. So there's still an awful lot of PLC 5s. This was probably really it was really used a lot with PLC 5. So any place if you go into a plant, you see a lot of PLC 5s, they're probably using DH+. Then let's talk about the big heavy hitter that's everybody knows and loves, is Modbus. Modbus is the 5th technology that I want to talk about today. So, of course, 2 different kinds of Modbus: the serial Modbus and the Ethernet Modbus. Serial is RS-232, 485, well, 230, it can be either one, mostly 485. And Ethernet one is what's called Modbus TCP. This is called Modbus RTU. So the big thing about Modbus is all the data, every device looks like 4 groups of 64K unsigned integer registers. So you say, I want to read this register set, this offset, and I want to read or write 16 bits of unsigned data. It only had one data type. What applications would do is take that data type and say, well, it's unsigned, but it's really, I'm going to use it as decimal, or I'm going to use 4 of these as floating point, or whatever you want to do. So they would define it differently. So Modbus is absolutely, millions of units were sold of this. So this came out about, I'm thinking, the late 1970s, and this was revolutionary technology. We didn't have any good way of moving data, a standard way between moving it. So Modicon came out with this, and all of their PLCs used Modbus, and it was a huge seller. And even today, you'll find a ton of Modbus. The reason is because it's really simple to implement. So anybody who's building any kind of device who wants to add communications to it goes, hey, we can add Modbus, because you just need a tiny bit of code to do it, and you can do Modbus communications. So there's a lot to be said for this. You'll find a ton of this all over industrial automation, all over the world. In our website, we get more hits on Modbus than anything else, because there's people who want to know about it. Now, so what we talked about today is we talked about DH+, we talked about DeviceNet, we talked about Profibus, we talked about OZBus, and we talked about Modbus. So what we do at RTA is we specialize in connecting these things up to your current architecture. So we can move a lot of this. We don't do much with OZBus. There's not much call for it, but the rest of these things, we can take this kind of data, move it into your current architecture, so you don't have to replace this. I mean, there's no good reason to rip out all that blue hose of DH+. We have a product now that can take DH+ and move it into a ControlLogix, or move it into wherever else you need it to go. So, that's kind of what RTA specializes in, is protocol translation. So give us a call if you have any of these old technologies. Give us a call, and our application engineers could help you figure out how you can solve your problem, get that data from all of this old stuff onto a new network, whatever it happens to be, some kind of Ethernet or whatever you happen to be using. If you're using Profinet or using Ethernet IP or whatever, we can help you move this data someplace else where it can become effective and usable. So that's what we do here at Real Time Automation. So this was my Mysteries at the Museum. If you want to, I have a bunch of this old crap in my office, and I call this the museum pieces, because I'm kind of a museum piece too. So thanks a lot. Look forward to talking to you in my next video.